Hi, so this is your review, guys, for your big benchmark. I'll probably do something similar like this for the STAR test as well. So after this video and after your test, let me know what you think of this video, if you liked it better or more or less than the Lightboard videos. But anyway, let's get started. All right, matter is our first category that we've learned this year, reporting category 1. Okay, remember we talked about how heavy each 4 categories are on the STAR test, meaning how many questions they ask generally. Okay, so let's start with matter. Matter, I got you here. My mom plays Roblox till Saturday evening. It just comes out to mass, magnetism, physical state, solid, liquid, or gas, relative density, does it sink or float? You know, MoFlow, we got a little oil, water, syrup. Less dense is on the top, more dense is on the floor, more floor. Teal, thermal conductivity. Solubility for Saturday, dissolves or not, okay? And then evening was electrical conductivity. And when you talk about conductivity, you're talking about can the electrons, can the energy flow through or not? If it's a conductor, it can keep on going. But if it's an insulator, it's going to stop. Because insulators hold it in. They don't let it go through. All right, mixtures. That's easily separate, something you can easily separate. Iron and sand, Chex Mix, salads, Fruit Loops, Lucky Charms, okay, all that good stuff. Solutions, not easily separated. Salt and water, sugar and tea, tea and honey, water and honey, okay? Those are all things that are not easily separated. All right, I also want to talk about water temperatures, okay? So in order to go from a solid to a liquid, the ice needs to melt, okay? And then if you want to take that liquid and turn it into a gas, right, it's got to evaporate. So in order to evaporate, you got to get it to 100 degrees Celsius, which is boiling. And then if you want to take that gas and then turn it back into a liquid, it has to condense, okay, which is your clouds up in the sky. So you can kind of use this too for a water cycle a little bit. You can figure out the connections here. And then finally, if you want to take a liquid, make it a solid again, you got to freeze it, 0 degrees Celsius. I added something over here, another little line arrow and a 0 degrees Celsius. That's to show that if you want to take a freezing will eventually melt, but when it does, it's got to start at 0 degrees Celsius. Okay. Also, so let's go back to the shower scene. We're always talking about it, but I want you to visualize it. Turn on the shower, okay? The water comes out. You've got a liquid because the water is a liquid. Then the liquid gets so hot, right? It turns into a gas. But in order for that to happen, it has to evaporate. That's the steam, the water vapor. But then that water vapor, okay, it hits that cold mirror and it starts condensing, right? That's what the little water droplets are on the mirror. And then, you know, after that, it runs back down when you're done. So when you open the door and all cools off, it all runs down, and then it's going away. So if you take your water cycle and you take this, you can kind of piece it together a little bit. Okay, because in order for a liquid to go back into a gas, it has to evaporate. So the sun has to heat it up, right? And then once it evaporates in the air, it goes up into that cold air, the atmosphere, and it condenses into clouds. It turns into clouds. And then those clouds just get so full they can't handle anymore, so they give up, right? And they just, all the water comes out, the precipitation. And so you can kind of match this to the water cycle, okay? All right, next. Energy, force, and motion. Reporting category 2, reflection. Anything, light can always reflect off any surface as long as it is smooth and shiny. Windows, lakes, mirrors, okay? As long as any of these apply, you can see your reflection in it. Okay, reflection is just the bouncing back of light rays. Why can you see yourself in the mirror every day? Because you can see your reflection. Light's bouncing off that nice shiny glass, right? Next, refraction. That's just when light hits an object and it bends. Glasses, water, contacts, cameras. Okay, light waves bend. Things look bigger or smaller. If you're wearing glasses on your face, think of refraction today. Okay, think of refraction. And then you should thank him. All right, light travels in straight lines. Definitely want you to remember that. Circuits. Let's talk about circuits. I'm trying to adjust this a little bit so we can get more. Circuits. Series versus parallel. One path only. Simple. Simple is easy. Easy, guys. Series. Simple. Easy. Series. Simple. Easy. One path only. Then you get parallel, and it's two or more paths. It's a little more complicated. Okay? And then when you have a path complete, either series or parallel, then you got to determine, is it open or closed next? Open, energy cannot pass through. Notice the sad face. Closed, it can definitely pass through. Notice the happy face. All right, moving on to 5 types of energy: mechanical, electrical, light, thermal, sound. Remember, mechanical is you sharpening a pencil, you smacking your alarm off in the morning, you writing notes, you playing your Xbox or your PlayStation. That's all mechanical. Electrical. Well, electrical is the wires and all the electricity that you need to make the Xbox or PlayStation work. Okay. Light energy. That's just light energy. Look up in the room. Look out in the sky. You see sun? You see lights? All right. Thermal, heat energy. Yesterday I had the heater on in the classroom because it was so cold. So thanks to the electrical energy, the air conditioning unit was able to produce us some thermal energy. And then last, sound energy. What did she say? Sound energy. And that's just when waves waves travel and you can actually hear it, right? What? Wait, what'd she say? All right, next. Force and spring scales. Force, Fortnite. Games, for me. Fortnite is friction. Games is gravity. For is force. Me is motion. Okay? What's going to stop a bear from rolling down the hill? Is it the gravity? Well, no, that's just going to pull him closer to the bottom of the hill. Is it force? No, there was probably a good strong force before that caused the bear to fall down. Okay? Motion, well, that's just him going, whee! He's in motion, right? So what's going to stop the bear from hitting the bottom of the hill? Friction, 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 friction. Remember, you can either have a lot of friction or you can have just a little bit of friction, but you always have friction. Kicking a kickball in the grass, what's going to slow it down? The grass, because it provides friction. So spring scales, okay, speaking of, measures the amount of force that's needed to move an object. So in order to move something from here to here, it causes force. Okay, it's actually quite heavy. This cup of pens is quite heavy. If it was empty, would I have to use as much force? No. So I put on here an empty suitcase versus an overpacked suitcase. So spring break is next week, and I'm going to be going down to my brother's, and my brother and his wife and his kid and all them people are moving. They're all coming down from Maryland, and so they're going to have to pack suitcases. Well, if it was an empty suitcase, would my brother have to use more force or less force versus an overpacked suitcase? Okay. My brother packs really light, so his suitcase will be pretty easy to carry. But my sister-in-law's, not so much. Okay, she's an overpacker, big time. All right, next. Moving on to reporting category 3, Earth Science. Fossil fuels. Fossil fuels are non-renewable. Oops, I just gave you that answer. All right, how many fossil fuels are there? 3. And how do we remember them? Because coal, oil, natural gas. Those are your 3 fossil fuels. So question, does something have to die to make fossil fuels? You better be saying no. Nothing? Ah, you better be saying yes, right? Yes, of course, something has to die to make fossil fuels. See, seeing if you're paying attention. All right, yes, something has to die to make fossil fuels, for sure, okay? Either plants or marine life, depending on what you want to make. But something has to die to turn into a fossil fuel. Well, think about it. It has the word fossil in the name. Fossils are replicas of something old and dead. All right, and last, are fossil fuels renewable or non-renewable? Better say non-renewable. Okay. Sedimentary rocks. Does something have to die for a rock to be made? Does something have to die to turn into a rock? No. But if you do want to make a rock, you just need a little bit of lead CC. Okay. We eat delicious chocolate candy. If you want to make a rock, you're going to need an old rock. Okay. And then first you're going to have to weather it. And when you weather it, you just need to chip at it with either wind, water, ice, something. You got to just break that rock away all the time. And then you're going to erode it. So then you're not just going to break it off, but then where are you going to get it from here to here? It's going to have to be carried, right? It's going to be erosion. And then when you finally put it over here, it's deposition. That's where it's landed. It's going to stay there. And then again, you're still making rock. So what you need to do, you need to get some more sediment and put it on top and on top and on top and on top and on top. Okay. You got to compact it. Press down, compaction. And last, how are you going to keep all those pieces of rock that you press together? How are you going to actually keep them together? Cementation. Remember, you're just going to pour some water over it. Make them all stick together like glue. All right. And up here, alternative or renewable energy. Okay, these can have two names. It can be considered alternative energy or renewable energy. Okay, I'm not sure how you'll see it on your test, but just know it always has two different names. They mean the same thing. It never runs out. Ever, ever, ever runs out. All right, 5 types. How do you remember? Silly Baxter wears green hats. S is solar, from the sun. B, bio. Hey, bio. Bio means life. Okay, bioenergy is like your corn that's turned into ethanol, you know, the gasoline in the cars. W, wind energy. G, geothermal, that's heat from under the earth. And then hats is hydro energy, water. All right, moving on. Let's talk a little bit about Earth and our solar system. My very educated mother just served us nachos. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And what is the big giant thing in the sky that's bright and orange and hot and is the center of our universe? The sun. Okay, and remember, we all revolve around the sun. All right. Earth, let's talk about that a little bit. Earth rotates every 24 hours, once every 24 hours, right? It's got a little axis thing happening, okay? And he spins clockwise or counterclockwise? Counterclockwise. Ah. All right, but Earth revolves around the sun every 365 days. So every 365 days, you have a birthday and you just completed one trip around the sun. Another, if you still get these confused, these two words confused, look at what I did here. I put rotate equals spin, revolution equals around. Look here, look at the lengths of the word. This word is shorter than that word, and that word is shorter than that word. So spin and rotate go together because they're shorter than these words that go together. I don't know if that helps you, but hopefully it will. All right. Ew, what is this? Ew. This is the sun moving across the sky every day, or looking like it moves across the sky. It really doesn't move. We move. But anyway, got a house here, got a sun here, got a sun here, got a sun here. All right. The sun has to come up and wakes up every day. That's why he's all happy. Okay. And he's going to travel across the sky every day. But when he gets here, what is it? It's noon, right? So that means everything up until this point is AM. Okay? And then from noon to sundown is all PM. That's why he's a little sags. He doesn't want to go to bed, but he has to go to bed. So the sun rises how? East to west. East to west. Ew, ew. East to west. East to west. Ew, ew, ew. All right, let's get talking about water cycle real fast. I didn't redraw it. I just want to point you out to this. Again, didn't we say that we could contribute some of this to the water cycle? Okay, so evaporation, evaporation. And then it turns into the clouds, right? And when it turns into the clouds, I'm trying to get this where you can see it. Then you've got condensation, condensation. And what happens when that cloud gets so full it can't handle anymore? Precipitation. So then that gas is turning back to a liquid. You see that? Okay. Maybe a little correlation there. All right. And then after precipitation, you've got runoff, right? Where the water just runs off and it comes back into the oceans or the lakes. And then it collects there until it's evaporated by the sun. All right. And let's talk about our last reporting category, category 4, life science. Life science, bio equals life. Bio equals life. That's why in 9th grade, you're going to take biology. You're going to be study of life. All right, ecosystems, abiotic plus biotic equals ecosystems. Ecosystems is just a living and non-living interacting. Example, humans need sun, water, and shelter to survive. Humans were the biotic, the living things, and we're relying on the non-living things to help keep us alive. It's amazing how that works. Food web, where the arrow goes, energy flows. All right, so you've got the sun, then the producers, then the consumers, then the decomposers. This is like a simple food chain, but it's actually accurate, right? The sun gives energy to the producers. The producers make their own food. See this? And then the consumers come and eat the producers. Okay. And then when the consumers die, then the decomposers come and eat on the consumers. Producer makes own food, plants, trees, and grass. Consumer eats food, animals and human. And then the decomposers eat on dead organisms like worms, vultures, mushrooms. Ew, gross. And last, we have 3 more things and we're done. All right, structures and functions. Organisms, body designs to help them survive. So why are you born the way you're born? Why do you have the things you have? Why do you have teeth? Why do you have a nose? Why do you have a mouth? Why do you have hands, a thumb? You're designed with all these cool systems and body parts and structures to help you function in life, okay? Beavers, they need teeth. Why? Because they got to cut them trees down to make them dams, okay? Polar bears, they have thick fur. Why do they have thick fur? Where do they live? They live in the Arctic. Well, it's pretty chilly there, I hear. So they need the thick fur to keep them warm. But why is their fur white? Oh my God, Karen, you can't just go around asking bears why they're white, but you can, really. So their white fur is to help them hide or camouflage in their environment, right? They live in the Arctic, where it's all white ice. So they have white fur that helps them hide from predators. Pretty cool, huh? Humans. Why do you have thumbs? Why do you have a nose? Well, you have thumbs so you can grab things, and you have a nose so you can smell. I mean, wouldn't it be awful if we were all walking around like mouth breathers? It would be terrible, wouldn't it? All right. Inherited versus learned. Inherited. Born this way, right? Eye color, hair color, flower color, skin color. Learned. A dog sits on command. Did he learn how to get the brown in his fur? No, but did he learn how to sit when you say sit? Yes. Seals balancing balls on their nose. Do seals get the choice when they're born if they have, I don't know, like weird feeling skin? No, they don't get that. But can they learn how to balance a ball in their nose? Yes. All right. And then squirrels eating from strangers. Again, that's a learned trait. The fact that he eats acorns, not so much a learned thing. That's more inherited. Okay. Because I'm sure he would like to maybe chew on some other things besides just acorns. It's kind of boring. All right. So when changes ecosystems, when the tree gets cut down that the little happy squirrel lives in, what's going to happen? Well, he's going to have to get mad, right? I mean, they chopped his house down. So what would you do? You would get mad. But what does that really mean? Well, he's either going to have to move and find a new tree. He's going to have to adapt and just say, you know what? I guess I'll just dig a hole into the ground and live there, hang out there with the groundhogs, right? Or he's just going to die off. Bye-bye. So this is it. This is your review. Guys, show your strategies. True, false, everything. True, false, everything. True, false, everything. True, false. Okay. Draw stuff out. Oh, yeah. Draw stuff out. If you don't understand what if the words are not making any sense to you, draw it out. Remember we did the stream with the little fish, right? So we could better understand the question. Square or circle in the question, especially if it's a long-winded paragraph or something, just square in the question, okay? What else is there? Anyway, true, false, draw pictures, square in the question. If you need to, chunk your words, like in the whole passage, but in the questions, chunk your words. If it's 15 words in a sentence, take 3 at a time and ask yourself, do I know what that means? Yes. Do I know what that means? Yes. Cross off the ones you definitely know are not true right away. Like if they have thrown some silly answers. Okay. And then last but not least, please, 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 please get rid of tricky trash. Tricky trash confused me last time. Tricky trash confused some of you last time. Tricky trash is awful. It's tricky. So remember if it said wind and then it had all the other junk, that was all tricky. I fell for it. Don't fall for it. All right. All right. So good luck, guys. Take care.